everyone. In today's video, we are going to cover solving systems of equations by graphing. Our learning target for today is I can solve a system of equations by graphing. Now, previously we've dealt with single equations where we just solved for x. Now we'll talk about a system of equations or two or more equations with the same variables. Now, the solution to a system of equations is a little bit different. Graphically, the point xy where the two lines intersect will be the solution. And then algebraically, it's the point xy that makes both equations true. So the left side equals the right side. Now, there are three different types of solutions when I talk about a system of equations. We could have intersecting lines when I graph. Notice that these lines meet at one point, so this is a one solution problem. I could have parallel lines. Parallel lines will never touch, therefore these types of lines will have no solution. And then I could also have same line, and the same line would be infinite solutions because they are the same exact line, one lying on top of the other. Now looking at steps to solve systems by graphing, first we'll want to rewrite the equations in slope-intercept form. We will have these equations always in slope-intercept form. It won't be until next year where you will have to rewrite equations in slope-intercept form. Second, we'll want to graph each line. Then we'll want to identify where those lines either intersect, or if they overlap, which would be infinite, or if they don't touch, which would be parallel. So we want to identify the solution that could be created. Now looking at some problems, we have problem 1, y equals x minus 8 and y equals negative 2x plus 1. So I want to graph both of these equations. So first, I'll look at y equals x minus 8. Now when I graph, I always start at my b, or my y-intercept. So I'm going to plot a point at negative 8. That's down here. Now my slope is x. X would be 1 over 1, so that means I'm going to go up 1 to the right 1. Now, in order to make this extremely successful, I can do two options. Option 1, I could use a ruler, or option 2, create as many points as possible like I'm doing to make the straightest line possible. If we don't make a straight line, our answer can be thrown off because the intersection could be different. Now I went up 1, right 1. This could also change to down 1, left 1, because that would also give me a positive slope. So this would be my line, y equals x minus 8. Now looking at y equals negative 2x plus 1, I'm going to start at positive 1. My slope is negative 2 over 1, so I'm going to go down 2, right 1. Now again, I'm going to continue this down 2, right 1, down 2, right 1, and notice right there was my overlap. Again, I can continue my line just to finish it, but that is my solution to this system. If I were to draw in two lines here, I would still see this regardless with my points, and these would be my lines where they intersect at that value. This value is the ordered pair 3, negative 5. So my solution to this system of equations is 3, negative 5. Now looking at number 2, I have y equals 1 half x plus 9 and y equals negative x plus 6. So again, I'm going to graph these. Let's start with y equals 1 half x plus 9. I always want to start with my y-intercept. So I'm going to plot my point at 9. And then my slope is 1 half. So I'm going to go up 1, right 2. Notice I can't go any more. So I need to go down 1 and left 2 because I could make 1 half negative 1 over negative 2 because a negative divided by a negative is still a positive. So if I go down 1 and left 2, that's the same as going up 1 and right 2. So I'm going to do all the points I possibly can for this line. Now I'll do y equals negative x plus 6. So I'm going to start at positive 6, which would be here. And then my slope is negative x, or negative 1, over positive 1. Or, again, I could do 1 over negative 1, because both values will give me negative. So if I went down and then right, there's no point in continuing in that direction because I know it's not going to intersect in those quadrants. I want to go up 1, left 1, up 1, left 1, and again, there is my intersection. Continuing my line just to finish, and drawing in my two lines would give me these two lines here. But I already know my intersection is the point -2, 8. So my solution to this system is -2, 8. Now looking at number 4, we have x plus 2y equals 4 and y equals -1/2 x plus 2. Again, I told you that everything would be in slope-intercept form, but I wanted just to practice this one. So I have x plus 2y equals 4. This is called standard form, and I want to change it to slope-intercept form. So I want the y by itself on the left side. In order to get the y by itself on the left side for x plus 2y equals 4, I'm going to subtract x from both sides. So I'd have 2y is equal to -x plus 4. And then I divide everything by 2 to give me y by itself. -x divided by 2 would be -1/2 x. And then 4 divided by 2 is +2. Now look at my system. I have -1/2 x plus 2 in my first equation. And then in my second equation, I also have -1/2 x plus 2. These are two of the same exact equations. Therefore, this is going to give me the same line, making my solution infinite. So if we graph this, again, they'll be the same line. So I'll start at 2, and then my slope is down 1, right 2, down 1, right 2, down 1, right 2, etc., etc., etc. If I draw in this line, it would look like this. And if I drew in the second line, it would lie right on top, making my solution infinite solutions. And now looking at number 6, again, I gave it to you in slope-intercept form this time. We didn't change it. You could practice changing it if you wanted to. We have y equals x plus 5 and y equals x minus 2. So looking at my first equation, I'm going to start at plus 5. So I'll have my point here. And then my slope is x, or 1 over 1. So I'll go up 1, right 1, up 1, right 1, etc. I can also go down 1, left 1, etc. Looking at my second line, I have y equals x minus 2. So I'm going to start at minus 2. And then again, my slope is positive 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. Notice in these two equations, I have different y-intercepts. However, I have the same slope. Whenever I have the same slope but different y-intercepts, these are going to be parallel lines, and it's going to be a no solution problem. Because when I graph these lines, notice that these are parallel lines, and they'll never touch. Therefore, this solution is no solution. In today's lesson, we learned to solve a system of equations by graphing, graph each line and determine where the lines intersect. If the lines intersect at one point, the system will have one solution. If they are the same line, the system will have infinite solutions. And if they are parallel lines, the system will have no solutions. That's a wrap on today's video. We'll see you in the next one.